Assalamualaikum warahmatullahi wabarakatuh. In this video, I will discuss some of the exercise that we haven't discussed during the last video under the topic 2.5, operation on function as well as composite function. First, let's look at to the exercise 1, question number 2. We have discussed question number 1. Now, let us discuss question number 2. We are given the function 1 over modulus of x plus 1 and gx is equivalent to x plus 2, and the question asks you to find out f, gx and its domain, and also for the part b, f over gx and its domain. So let's look at to the first part. So we want to find out f gx, which is the product between two functions. So f gx is equivalent to 1 over modulus of x plus 1 and then times with the x plus 2. So we can just write down like this, or we can just put it as x plus 2 over with the modulus of x plus 1. And how about the domain? So the domain for the product, sum and also the difference between function is equivalent to the domain of the f, and it must be intersect with the domain of the function g. So what is the domain of the function f? So since we have rational function here, so what makes the denominator 0 is the values of negative 1. So x cannot be negative 1. Therefore, the domain in terms of interval notation from negative infinity until negative 1 union negative 1 until infinity. Therefore, the domain for the product between these two functions is negative infinity until negative 1 union with the negative 1 until infinity. Why? Because the domain for the function g is all real number, negative infinity until infinity. So intersect between these two domains. Therefore, you will just get negative infinity until infinity, negative infinity until negative 1, and negative 1 until infinity. Now, let's look at to the part B. So, for the part B, we want to find out the quotient. So, f over g, so this is for the part B, f over g is equivalent to f gx. So, f over gx, so is equivalent to 1 over modulus of x plus 1 over with the x plus 2, or you can also rewrite as 1 over modulus of x plus 1 times with the x plus 2. So, this is the function f over g. And then how about the domain? So the domain is just intersect between f and also function g, and but we do have the additional condition whereby the function of gx cannot be 0. Therefore, x plus 2 cannot be 0. Therefore, x cannot be negative 2. Therefore, the domain of the f over g is, since we do have these two conditions, x cannot be negative 2 for the f over g, and it must be also intersect with the domain of the f intersect with the function g. So for the f intersect with g, just now x cannot be negative 1. Therefore, the overall domain, which is domain f over g, is negative infinity until negative 2 union negative 2 until negative 1 union negative 1 until infinity. So this is the domain for the quotient. Now let's proceed with the exercise 2, question number 2. The function fx and gx are defined on the set of real numbers by fx is equivalent to x minus 1, gx is equivalent to x squared plus px plus q. So we do have two unknown here, p and q, and given that g composite f is equals to x squared minus 9, find p and q. So from the composite function, so let us put our composite function here. So our composite function, which is g composite with the function f, is equivalent to given x squared minus 9. And then g, which is, we do have the inner function f, so substitute the inner function, which is x minus 1, given is equivalent to x squared minus 9. So this function, the function on the left, which is g of the x minus 1, is equivalent to the x squared minus 9. So, and the gx given as x squared plus px plus q. So, we need to substitute x in the function g given in terms of x minus 1. So, when we put the x as x minus 1, so you will get x minus 1 squared plus with the p x minus 1 plus q is equals to x squared minus 9. So expand the equation here. So x squared minus with the 2x plus 1 is plus with the px minus p plus q is equals to x squared minus 9. Then x squared plus, so we need to put the terms with the same x here. So we do have only one x squared. So and then we do have the terms of x in terms of p minus 2 in bracket x. So and then without x we have the terms of plus 1 minus p plus q is equals to x squared minus 9. So what we need to do here is we need to compare the term on the left hand side with the terms on the right hand side. So what you will get here, as you can see on the left hand side, we have x squared, x squared. So we have the unknown p on the second term, which is the x term, which is p minus 2, and we don't have the terms of x on the terms on the right hand side. Therefore, we just put as p minus 2 is equals to 0. Therefore, we get the first unknown p is equals to 2. So once we get the values of p, of course, we can get the values of q from the last term, which is 1 minus p plus q is equals to negative 9. So we put here as 1 minus p plus q is equal to negative 9. Substitute p with the 2. So 1 minus 2 plus q is equals to negative 9. Therefore, negative 1 plus q is equals to negative 9. Therefore, you will get q is equals to negative 8. So this is for the part A, the p and also the values of q. P is equals to 2 and q is negative 8. Now let's look at to the part B. Hence find f composite g of negative 1. So when there is the word hence on your question, meaning that you need to use the information that we get on the previous part on that current part. Let's say for this case, you cannot put your f composite g in the form of p and q unknown because you already get the values of p and q. Therefore, you need to substitute the values of p and q whenever you have p and q in the terms of f composite g. So for this case, what you need to do first is you need to find out the f composite g. F composite g is equivalent to, so we need to put as f. So the function g is x squared plus px plus q. So since this is your x, so you need to substitute x with the x squared plus px plus q. So this is our x. So the function of g is x squared plus px plus q. So and then the function of f is x squared plus px plus q. So this is our x. So we substitute under the function f. X is x squared plus px plus q and then minus 1. So substitute p with the values of 2x squared plus with the 2x and q with the values of negative 8 then minus 1. So you will get x squared plus 2x minus 9. Therefore, the question asks you to substitute f composite g with the values of x is negative 1. So negative 1 squared and then plus with the 2 negative 1 minus 9. So you will get the answer is negative 10. So this is the values of the f composite g with the x is negative 1. So the answer is negative 10. Now let's look at to the last question on the composite function. Question number 6 on the exercise 2. The function h and g are defined on the set of real numbers by hx is equivalent to 4x squared plus 36 and gx is equivalent to square root of p. If given h composite g is equivalent to 4x squared, find p in terms of x. So we need to find p. So what we have to do here is, so given that h composite G is equals to 4x squared. And then we have H. What is the function of G? It is square root of P. So it is equivalent to 4x squared. And then the function of H is 4x squared plus 36. So we need to substitute x squared with the square root of P. We need to substitute x with the square root of P. So you will get here 4 of the square root of P squared, because we do have squared here, and then plus 36 is equivalent to 4x squared. So square root of P and then squared, you will just get P. So 4P plus 36 is equivalent to 4x squared. So we can simplify everything by divided everything by 4. So you will get 4 plus 9, which is divided by 4. You will just get P here. So P plus 9 is equals to x squared. So at the end, we can just put P as a subject because the question asks to find out P in terms of x. So P is equivalent to x squared minus 9. So this is the P. And then for the part B, we want to find out the domain of the function G. So what is the function of G? So since we already get the terms of P in terms of x, so we can substitute P as x squared minus 9. So we need to find out the domain of this function G. So since it is under the square root of even number, therefore any terms inside the square root of even number must be greater than equals to 0. So what we need to do in order to solve this inequality, so we have to factorize completely. So you will get minus 3 and plus 3 here. So there are two ways for you to solve this quadratic inequality. It's either by using quadratic graph, or you can also use the sign table. So the second method is by using sign table. So since we have in terms of quadratic is better for you, it will be more easier for you to solve by using quadratic graph. So draw the smile graph because you already have positive 1, which is your A is already 1. Your A is positive number. So you will have smile graph, and we need to put the zeros here. We have negative 3 and 3 as the zeros. And since it is bigger than equals to, so the shaded area is on the left and on the right, or it is above that line. Therefore, the domain of the function G is negative infinity until negative 3, close union, close 3 until infinity. So this is the domain for the function G.